Hey everyone, welcome back to Swift Fundamentals. Today we're tackling two essential concepts, generics as well as higher order functions. Generics enable type-safe, reusable code, while higher order functions simplify array operations like transforming, filtering, and reducing data. By the end of this video, you'll understand how these two tools can streamline your Swift code. Let's go ahead and dive on in. Let's go ahead and start with generics. So these allow us to create those flexible functions and types that work with any data type while being type safe. So let's go ahead and create a function here. And I'm going to say generic sort. And we're going to use our kind of angled brackets here. So those greater than and less than signs. And we're going to say t colon comparable. And then we're going to wrap that in the other kind of angled bracket there. We're going to then pass along parameters. So we're going to say underscore array. Then I'm going to, within this array, put the t. And then we're going to return. So I'm going to do dash arrow, the array with t inside of it. Okay, so this is going to be a generic function in order to sort an array, and within here we're going to need to return array dot sorted. So this is going to use the built-in sort method. So what is t? T is kind of like our placeholder, and we can pass in any data type that we'd like. So we're basically going to be able to use this as an integer. We can use it as strings, right? We're kind of just using this t as a placeholder to, pass any data type in. So let's go ahead and create some examples so we can see it in real time and how it can handle all of the data types. So let's go ahead and create some numbers. So I'm going to create a constant, let numbers. Let's make this an array. Let's just put some random out of order numbers as we go. Cool. And let's also now create a sorted numbers. So we'll say let sorted numbers equals, and we're going to call upon our generic sort, and within these parameters we're going to reference the numbers here. So I'm going to put in numbers, and let's go ahead and print out those sorted numbers. I know we can see it on the right side there, but I always like to do a print statement, and that's going to, we can see here 3, 6, 8, 10. So even though we were saying t comparable array return t, right, it's going to take that data type and it's going to be able to work with all of them. So let's see now how it could also be applicable to strings. So let's say let words equals, we can have an array here, apples, oranges, bananas, peaches. Okay, and then let's do the exact same thing. Let sorted words equals, and then we'll do the generic sort, and from here we'll reference those words and we can print sorted words. So this is going to sort them in alphabetical order, so we now have apples, bananas, oranges, and peaches, right? So on line 1 with the function generic sort, we're declaring a generic function with the placeholder type t. Then constraints to t conform to comparable, ensuring that only types can be compared can use this function, right? So we can't compare an integer to a string. So because it's comparable, it ensures and only will run the function if the data types we're passing to it are all the same. So all integers, all strings, all doubles, right? It won't connect the two. We then use the sorted method in order to sort the numbers from smallest to largest and the words in alphabetical order. And then we use these examples here to kind of show how they work. So this example highlights how generics eliminate redundancy by enabling a single function to handle multiple types as long as they conform to the comparable protocol, which is a built-in protocol. All right, now let's talk a little bit about higher order functions. So these are things like map, filter, and reduce, which are really great for transforming and manipulating arrays effectively. Let's go ahead and break them down. So I'm just going to delete everything and I'm going to create a new numbers here. I'm going to have it equal an array. Let's have it be 1, 2, 3, 4, 5. And now let's go ahead and double the numbers, and we're going to use map for that. So we'll say let equals numbers dot map. Afterwards, we need to provide a brace to kind of say, okay, what are we doing with each one of these numbers? And we're going to use the $0, and that's basically going to start us off at the first element in the array, and then we'll say times 2. So now let's go ahead and print doubled. So our first line here, that creates the array of integers. Then we apply the map function to iterate over each element, doubling its value using the closure. Okay, so it's going to say for each one of these elements, starting at element 0, I'm going to double each and every one of them, and then we can print that new array. So map is perfect for transforming data, such as scaling numerical values or converting data formats. Let's quickly talk about filter. We're going to create a quick filter to find even numbers, and we'll use the exact same array here. So let's go ahead and say let evens equals numbers.filter. Going to add our brace, $0, and then we're going to do %2 equals 0. And let's go ahead and now print out those evens. All right, cool. So we can see on line 5 here that we're applying a filter to only keep elements where the condition is, true. So in this case, anything that divides evenly into 2, right? So that remainder would be 0. Then it would keep those numbers. So we can see here from our 1, 2, 3, 4, 5, only 2 and 4 have been kept, as only those numbers divide evenly. They are even numbers, right? So filter is useful for narrowing down data sets based on conditions, like finding a specific type of users' items. All right, and let's go ahead and explore reduce. So let's go ahead and create a new constant. Let's call this one sum. This is actually going to add all of the numbers in the array together. So I'm going to say equals numbers dot reduce, and then we're going to actually add brackets here. And in those brackets, we're going to put 0. We're going to add a brace, our $0 again, space, plus, then we're going to do $1. Let's then print the sum. So we can see that equals 15. So essentially what's happening is we're applying reduce to accommodate the sum of all elements in the array. So we start with the initial value of 0 and iteratively add each element to the running total. And then finally, we print out that sum. So reduce is ideal for combining data into a single value, like calculating totals or averages. So when you're applying any of these to your program, you'll be able to put your code logic between these braces and do whatever you'd like to do. Alrighty, let's go ahead and combine everything we've learned today from generics and higher order functions. What we're going to do is we're going to filter and transform within a function using generics, and then we'll use those higher order functions to do the dirty work. All right, so let's create a new function here, and we'll say filter and transform. Okay, let's use generics. We're going to use those angled brackets here, and I'm going to say t. And if we want to have another one, we can also say u, right? We're going to have 2 generic values within here. We're going to close off those brackets, and from here we can add our parameters. So I'm going to say underscore space array colon. We're going to reference that t within the array. And then after array, we're going to add a comma and say filter condition. Then in brackets, we're going to put our t, and we're going to return a bool, comma, transform, colon, normal brackets, t, then we're going to return u. Close out our brackets. Let's go ahead and exit that, and we're going to make another return, and it's just going to be an array of u. So this looks a little funky, but essentially what we're doing, and we also need to add a brace here for our code. Essentially what we're doing in this long statement of declaring our function is we're declaring a generic function that works with 2 types, t, which is going to be our input type, and u, which is going to be our output type. So here we're saying we're using 2 generics, t and u. We're then going to have our array t. We're going to apply the filter condition. Then we're going to transform t into u, And then at the very end, we're returning the value or the generic U. Okay. Now we do have an error here because we do need to eventually return something. So let's go ahead and add our return, which would be an array. So we're going to turn array dot filter, and then we'll do our filter condition, and let's do dot map, and then we'll just put transform. Okay, so this is going to use filter and map within the same function to first filter the array and then transform the filtered results. If this seems a little bit confusing, once we go through the example and usage, I promise it'll make sense. Okay, bear with me. All right, let's create an array of numbers here. So I'm gonna say let numbers equals, let's have 1, 2, 3, 4, 5 again. Then we're going to create a constant and we'll call it filtered and doubled. Have this equals filter and transform. All right, so we're going to use the autofill feature here, so we can just grab all the things required from our parameters and plug it on in. So for the array, well, this will be our numbers that we've just created above. For the filter condition, this is how we want to apply the code within the filtering. So we're actually going to add a brace here, and we're going to have our $0% 2 that we created before equals 0. So this is going to keep only even numbers. And for the transform, let's go ahead and add our brace one more time. $0 space times 2. So we've applied 2 different conditions, right? So this is going to double each even number. Let's go ahead and see how this works. Let's print our filtered and doubled. We should have the result of 4 and 8. We absolutely do. All right, so I'm just gonna go over everything one more time. Like I said, for me personally, when I kind of, see it in action, and we can even, play around with these numbers to kind of see the different results, it tends to click a little bit better for me. But I'm just gonna go over everything one more time here. So on line 1 here, we've declared a generic function that works with 2 types. T, our input type, and U, our output type. Then we use filter and map within the same function right here. So our filter condition map.transform to first filter the array and then transform the filtered results. Down here, we're just demonstrating how to pass the closures. Again, use your autofill when you can. And for the filter condition, right, this is where we have the map. So we're gonna, find every even number using our formula from before. And then in transform, this is where then we're going to take all those numbers that have made it through the map. So after we've kept all the even numbers, we're then going to double them. Okay. So this example illustrates how generics combined with higher order functions can handle complex tasks in a clean, reusable manner. And that's a wrap. Today we explored generics for reusable type-safe code and higher order functions for transforming and aggregating arrays. By combining these concepts, you can write more concise, powerful Swift code that's very applicable. Thanks for watching, and remember, dream big, code bigger, and have a good one.